Hi there, I'm Mike from Prep 101, and in this primer we'll be going through stoichiometric conversions. That's how to transfer from one species to another. This is absolutely essential to any chemistry course and is going to be built upon in later chemistry courses. Let's start out with a relatively easy example to help train your intuition. This one asks, a warehouse with excess bike frames wants to make 100 bikes. How many wheels must they order? So, we need to balance this first. Well, intuitively we probably know that it takes 2 wheels and 1 frame to make 1 bike. If we didn't know that, we would look at this coefficient down here, this subscript. We see that we have 2 wheels on the right-hand side. As a result, we're going to need 2 wheels on the left. So now they tell us that we have excess bike frames, which means that we're not going to need to consider how many frames we're going to need. We have as many as we need. If we need to make 100 bikes, then we're going to require 100 times 2 wheels. We're going to need 200 wheels. What I'd like to do now, though, is consider this in a slightly different way. The number of wheels that we're going to need is going to be equal to the number of bikes that we want times something. Now, we've already seen what the times is going to be equal to up here. But let's pretend that our intuition wasn't so good. Let's pretend that this was a more difficult situation. We can actually do this with unit canceling. So we're going to say the number of wheels is equal to the number of bikes, we already know that, times the coefficient in front of the wheels and the bikes. Now, a lot of people get this mixed up. A lot of people are like, which one do I put on the top? You're going to put the one on the top that you're looking for. So you know you have 2 wheels and the coefficient in front of the bikes, the wheel 2 frame, the bikes, is just a 1. So our bikes are going to now cancel, and our number of wheels is going to be 100 times 2 is going to be 200, just like we found above. Now let's do a trickier example. We're told airbags are inflated largely by the following reaction. We have some NaN3 going to sodium and nitrogen. To reach a final volume of 60 liters, 2.45 moles of nitrogen are necessary. How many moles of NaN3 are required? Take a moment, pause the video, and give this a go. Alright, let's see how that worked. Like before, we're going to use the canceling method. So we're looking for the moles of NaN3. And that's going to be equal to the number of moles of the nitrogen times something. Let's see, we always have the thing that we want on the top, so we're going to take the coefficient on top of NaN3 divided by the coefficient on top of nitrogen. All right, and let's sub those numbers in. So we want 2.45 moles of nitrogen. We multiply by 2 over 3, and when we do that, we get 1.63 moles of our NaN3 being required. In summary, make sure that you have the coefficient of the thing that you're solving for on top when you're using those mole ratios. In the last example, we had 2 over 3 NaN3 over nitrogen 2 because the thing that we were solving for was that NaN3. When you do that properly, you're going to find that the things that you don't care about cancel, and you're left with the thing that you care about. I hope you found this video helpful. If so, check out others like it, outlining the foundations of first-year chemistry in this Primers playlist. Also, be sure to join the Facebook Study Hub group. I'll put a link in the description so you can find it easily. And finally, I hope to see you at our preparation sessions. This is where I'll be outlining how to do so many questions so you can go into your midterm and exam with confidence and earn top marks. Many of the midterm preparation sessions are actually free. That's right, free. Go to prep101.com for more details. Thank you for watching.